Thank you. I think Professor Nagi needs no introduction. He's been to many of our workshops. So we will just get on with the lecture. Thank you, Nagi.
Thank you, James. Thanks. So my topic is a little unusual for endoscopy, especially in the live endoscopy course. I'm going to talk on green endoscopy. Now, before I go into the green endoscopy bit, I think it's very important for all of us as gastroenterologists and endoscopists to learn what this green endoscopy is. So when you actually Google this and put on your net what is green, you'll find green foods, there's a green practice, green energy, green patents, everything. So many greens are there. So you get a huge number of response to green. So green endoscopy, I didn't realize it till recently how important it was and how much linked it is to climate change. So the first thing is, why should we bother about this at all? How does it affect us as gastroenterologists or endoscopists? I think it's important for us to realize what it actually means. What happens normally is there's a lot of carbon dioxide produced by various human animal activities. This carbon dioxide gets trapped into our atmosphere, and what it does is, because of this, it keeps the temperature of the planet a little warm, an ambient temperature, and because of this, of course, again, wildlife thrives, the plants thrive, and so on, and the optimum amount of carbon dioxide is released. So it's a cycle which keeps the earth moving in a proper way. But what happened, it's a perfect balance. So what has happened recently is industrialization. There's excess greenhouse gases that are produced. These greenhouse gases get trapped in the atmosphere, and this results in an increased global temperature. This increased global temperature results in global warming, and global warming makes Earth an inhabitable place. So this is a simple cycle. Now when we mean greenhouse gases, not just carbon dioxide, but a variety of other things also that can produce problems. And you can produce this not only just by for example, atmospheric carbon dioxide, but even, for example, you want to buy a shirt, you're going by a car, traveling by aircraft, everything contributes to so-called global footprint. So global footprint is increasing because of not only increased carbon dioxide, but variety of other gases that we also use in medicine, for example, nitrous oxide and so on. If you look at equivalence, one methane is equivalent to 25 carbon dioxides. One nitrous oxide is equivalent to 298 carbon dioxide, which means that these other gases, greenhouse gases, also have an increased capacity to produce the same effect as carbon dioxide with a much more enhanced potential than even carbon dioxide. So what happens now is, normally when this carbon dioxide gets trapped like this in the atmosphere, it increases the temperature, and this global warming has resulted in some alarming features. If we look actually at the carbon dioxide levels for we have data for more than 800,000 years, you'll see that the present carbon dioxide levels are the highest that we've had for many, many years now. We're reaching very high levels. It was maintained at a certain level for many years, but now it's reached very high levels. So this global warming gives rise to droughts, it gives rise to wilder weather, excessive rain, snow, more melting glaciers and therefore floods, more forest fires, and rising sea levels. All these have, of course, consequences. And if you actually look at what's going to happen in the next couple of years, we realize that a 4-degree increase centigrade of global temperature can give rise to terrible consequences. For example, I think we won't be able to live anymore in our country, at least. Many of the African countries and South American countries will no longer be inhabitable. So that's the reason why the climate committees are trying to see if we can restrict this rise to less than 2 degrees centigrade. But I think there's a lot of politics involved in that, and looks like unlikely that we will do it. So why do we have to care as doctors for this? The reason why we have to care is that healthcare delivery also is related to climate change. It's actually a very important equation. Healthcare is contributing to climate change, and climate change is contributing to healthcare problems. For example, because of climate change, there are several things that give rise to rising temperature, air pollution, and the vector ecology is changing, water quality is changing, diarrheal diseases are changing, and so on. This is a problem. And how do we contribute? In fact, healthcare industry contributes 4.4% of total global carbon footprint. United States account for 27% of global print and 10% of the carbon footprint in United States is because of healthcare industry. 7% of carbon footprint in Australia is because of healthcare. 5% in Canada and 3% in the rest of Asia. So you see, there's a huge amount of carbon footprint that we are contributing to from healthcare. And if you look at healthcare itself, you'll find that GI endoscopy is the third largest contributor for this. After surgery and intensive care, it's very surprising that I'm surprised when I look at these figures that actually GI endoscopy is the third largest contributor to this carbon footprint of greenhouse gases, resulting in the problem that we have. So how does endoscopy get directly involved? Of course, there are direct emissions because of the carbon dioxide used in endoscopy, emissions from electricity, indirect emissions from products and services. So let's look at each of these carefully. For example, all our endoscopies are now done with carbon dioxide. We no longer use air. We use nitrous oxide for anesthesia sometimes, and if you can remember, one nitrous oxide is equal to more than 200 plus carbon particles. For reprocessing, we use a lot of other activities to contribute to carbon dioxide, and of course, we use disposable accessories. And a lot of plastic is used. In fact, it's calculated that a significant amount of plastic waste also is used with endoscopy. Let's go to each of this and look at this. What about reprocessing endoscopies? Each endoscopy washing machine incurs a significant amount of carbon dioxide addition to the atmosphere. For example, in our institute, we have 40 machines working all the time, and you can calculate how much of carbon dioxide this is adding each time we reprocess. Similarly, if you're looking at disposable accessories, with COVID coming in and a lot of other infections, we're starting to use all these plastics. Most of them are not recyclable and therefore add to our carbon dioxide wastage. Per bed per day, 1.5 kg of plastic waste, and in some, for example, the Japanese Endoscopy Society has calculated almost 3 kg of plastic waste per day per bed. Most of these disposables are in form of surgical gloves, syringes, and you can see it's very difficult not to use them. 15% of the hospital plastic waste is actually biohazardous. We use a variety of plastics from syringes and so on. Each of them have a different bioavailability in terms of carbon dioxide. And of course, we have different bins where we dispose them off, and I'll come to that a little later, why this is very important. The red bin was the one which contributes to major carbon dioxide output into the atmosphere, and you can see all our syringes, IV sets, all these normally go into the red bin. So, in addition to the solution, how can we overcome this? Of course, we can use we can of course use accessories which can be reused using ETO or plasma, but again, there's a lot of resistance both from the industry and from regulatory agents. As I said, in Japan, for example, 3 kg waste per day per bed, whereas we have reduced it to 1 kg of waste per day per bed in our own institute. So all these things can be implemented. Of course, what happens is the major part of the plastic that we use go into landfills like this. And when they go into landfills, there's a bacterial layer formed on the landing, and a huge amount of methane is actually exposed to the atmosphere. So this can only be changed if we can start reusing or recycling plastics to some extent. Instead of going to the landfills or getting combusted, we are trying to use a new technology in our own institute where all these plastics actually go into a special machine, which then processes them. And from this machine, we get actually either a small amount of carbon, or we get fuel like diesel or gasoline, which can be used. And this fuel is made of a different molecule, so that it doesn't contribute so much carbon dioxide to the atmosphere. So what we're advocating now is that instead of throwing off your plastics or putting them in landfills, as is done in most cities all over the world, we start using these recyclable techniques where these plastics can be recycled into a different type of output either as a fuel or as a small amount of carbon used for manure and so on. Now, if you look at, as I told you earlier, we have two types of waste, the regulated medical waste, which is going into a special bin, and of course the standard waste. It's a regulated medical waste which is contributing more to carbon dioxide in that environment, and one of the ways to decrease our plastic waste is to sort out some of these regulated waste into standard waste where the contribution is less to carbon dioxide output. In addition to this, there are a lot of other areas where endoscopy unit is contributing to carbon footprint, computers, anesthesia machine, washing machines, and for example, even lighting. We put these lights on 24 hours in endoscopy units without switching them off, and this itself also contributes to the problem. So again, we have calculations saying how much the computers, how much the anesthetic machines, how much washing machines contribute. So these can be very rationally used, carefully used. We can probably decrease this. And one of the ways we can do it is, of course, for example, electronic endoscopy reports. Instead of printing out all our endoscopy reports, they can be stored electronically and sent out as electronic medical records to the patient on smartphones and so on. So therefore, the printing process comes down and we save a lot in terms of paper and carbon dioxide going into the atmosphere. So this is very important. But the most difficult problem is how do you replace carbon dioxide? Carbon dioxide is now being used because we know it's rapidly absorbed from GI tract when there's perforations or leaks. This doesn't cause any problem. We no longer can use air in many of our advanced endoscopy procedures, like, for example, third space endoscopy and so on. We are now actually working with Kansas VA unit along with a company called Greenco, where we're trying to see if carbon dioxide can be replaced with other inert gases. Of course, we can't use nitrous oxide because it has problematic nitrogen, because it's not absorbed so well from the gastrointestinal tract. Hydrogen can be used, but the problem, of course, we now have hydrogen cars and so on. The problem with hydrogen is it's combustible. So we're trying to see if we can make this hydrogen into a less combustible gas so we can use it in endoscopy. And I think it's some way off, but the major way to decrease endoscopy contributing to these greenhouse gases is to decrease the use of carbon dioxide in endoscopy. Is there an alternative? Should we go back to air for our diagnostic endoscopies and come to carbon dioxide only in therapeutic endoscopies? This is something that endoscopic societies have to think about. So in addition to all this, I think the way to decrease carbon footprint from endoscopic procedure is efficient strategy to minimize waste, smart utilization of the equipment and other strategies. So if you look at total endoscopic procedures, you'll also realize those procedures which are really needed in the patients have several problems which can be addressed. But there are also wasteful procedures which are done because they're economy driven, because the incorrect indication and so on. These can of course be cut off. So I think one of the ways to decrease carbon emission is to decrease these wasteful procedures. So how do we decrease carbon emission from endoscopy? There are some very low hanging fruits that are involved. For example, the easy wins are recycling waste in a proper way, waste segregation, reducing paper use with electronic reporting, reduce the cost of lighting, heating, and so on in endoscopy units. There are other intermediate target which requires like reduce plastic containers and minimize the workforce and so on. But the long-term strategies are also important, but these are expensive and they are going to be global strategies. For example, new technology to replace diagnostic endoscopy, use of artificial intelligence use, reducing single-use consumables in endoscopy and so on. So these are going to be challenges that we are going to face, and the many challenges are because of lack of research, lack of awareness, the massive waste that actually we produce every day, and entrenched medical practices that can't be easily changed. So it's going to be a tri-party cooperation that's important, hospitals or institutions along with the government and endoscopic manufacturers. It's very important to remember that endoscopic manufacturers, a huge amount of economy is involved in this, and to actually ask them to change their behavior, to change from single-use devices to reusable devices again, is going to be extremely difficult because of regulatory problems, potential chance of infection, and so on. Now, as gastroenterologists, how aware are we and what should we do about it? In fact, this was a very interesting survey done by World Gastroenterology Organization. And what they found was that a vast majority of doctors do accept climate change. They all believe that it's caused by human activity, but very few are doing anything about it because they do not see it as a core business. In fact, very few are actually aware that endoscopy is such a major contributor to greenhouse gases and that in some way we are influencing climate change indirectly. Fortunately for us, this awareness is creeping in now. There is a green endoscopy network of gastroenterologists, mainly driven by gastroenterologists in UK and other places, where we are advocating methods to decrease green endoscopy. And what we are trying to do at AAG is to try and produce net zero carbon endoscopy units at least in the next 5 or 6 years. And this would occur by several processes shall come to that, but I think this is what we try to aim at. And this is a recent paper that we just published in GUT, where how do we decrease or make carbon zero endoscopy units? Pre-procedure, we'll try to target and see that we decrease paper communication to our patients, prioritize high-yield procedures, use telemedicine in a way to decrease patients coming to the hospital. Intra-procedure, of course, judicious use of instruments. So, for example, if you're doing a polypectomy of multiple polyps, instead of using multiple snare in a patient, in one patient you can use one snare and get away with it. Appropriate waste disposable and thoughtful use of PPEs. We know that COVID is now coming down and maybe you don't have to be so heavily protected as we used to be. Of course, post-procedure is paperless digital communication. We require virtual patient follow-ups and energy-efficient smart devices, both in endoscopy and pathological units. For example, maybe we should strongly advocate resect and discard rather than sending all the specimens to pathology and so on. So these are how we can actually reduce carbon emission and what we call healthcare without harm to our patients. Thank you very much for your
Thank you, Nagi. Very interesting, a whole new concept.
Yeah.
I think the only way to reduce carbon emission is not to do endoscopy, I guess.
I think we should come to that in terms of at least maybe screening colonoscopies, how we can reduce, maybe using more capsule and so on. But I think this is interesting in the sense that we are contributing so much to carbon footprint.
But this is very much against the current trend of disposable endoscopes and disposable accessories and so on and so forth with the infectious risk concern. So,
so this is an interesting topic, James. In fact, I didn't touch on it because it will produce a lot of controversies. For example, there is evidence that using disposable stuff can increase your carbon footprint by 40%. But also, on the other hand, there's a very interesting study which was actually supported by one of the disposable scopes companies. The Ambu company did this study where they showed that disposing of scopes in a proper way and recycling many of the parts can cause less carbon emission rather than the standard endoscopic disinfection process. But I think this is company sponsored, so you have to be very careful. But maybe even if you produce disposable stuff, for example, like disposable endoscopes, we should see that these endoscopes are going to be recycled. At least many parts of the endoscopes are recycled. Only a small part is actually disposable. And that way I think we can actually save carbon footprint.
Okay, yes, that was a very thought-provoking talk. Thank you, Nagi.
Thank you, James. Thank you.
I think we'll move on. Thank you again for your very nice lecture. It's very illuminating. Thank you.